Welcome to Real Civil YouTube channel. In this video, I am going to explain you the problem of a three-story building. Okay, so this is a three-story building. Okay, this problem I am going to give you as a homework. Okay, so we are going to focus on this building, which is a three-story building, and we are going to determine the natural vibration frequency and modes. Okay, so first thing we are going to calculate is natural frequencies. Second thing will be mode shapes. Okay, here in this example I am not going to take particular values, so I am going to calculate it in terms of m, ei and h. Okay, and we'll sketch the modes, how to draw the mode shape and identify the associated natural frequencies. Second, we will verify the mode satisfy the orthogonality properties. Okay, so these two questions we are going to cover. So this is the problem under multi-degree of freedom system, and in multi-degree of freedom system we are going to see how to determine the natural frequency and mode shapes. And I am going to show you one simplest way of calculation. So even you have values, you have to put it at later stage. Most of the part you have to follow as it is, even if you have the numbers with you. Okay, so this is our structure. This is first, second, third story. The mass is m by 2, that is 0.5 m. These are rigid beams, that means the connections are fixed, the bottom is also fixed, the height of each structure is h. Okay, so our very first step is we have converted the problem into lumped mass system. So this is called as lumped mass approach. So what we have done here, so the same structure we have converted into this form. Okay, so this mass m, this is the mass m, and this is 0.5 m. Okay, and this is k, this is k. So as these are in parallel, this becomes 2k, 2k and 2k. Okay, so first step is we have to convert the problem into lumped mass system, or in a simple way. Okay, so our first step is we have to prepare the mass matrix and stiffness matrix of the system. For lumped mass system, our mass matrix will always be m1 0 0 0 m2 0 0 0 m3. So for lumped mass system like this, it is not going to change. So m1 m2 m3, a diagonal matrix is there. So we have taken out the common m. So 1 0 0 0 1 0 0 0 0.5. This is the first story, second story mass, and this is third story, as you can see here. Okay, now next step is we have to prepare the stiffness matrix. So again, for such type of example, the general way is stiffness matrix K is K1 plus K2 minus K2 0 minus K2 K2 plus K3 minus K3 0 minus K3 K3. So this is the general stiffness matrix. If you want the derivation of the same, we can derive, but it will take a little time. Okay, so you can remember for three story and for such type of example, you can refer this as a template. Okay, so this is K1, this is K2 and this is K3. Now K1 plus K2, okay, that means 2K plus 2K, so it is 4K, minus K2, that is minus 2K, so minus 2K, 0, minus K2, minus 2K, K2 plus K3, K2 plus K3, 2K plus 2K, 4K, minus K3, so minus K3 means minus 2K, 0 minus 2K means minus K3, K3 is 2K. So this is very simple and we have taken out common K. So this is our mass matrix, this is our stiffness matrix. Now we have to determine eigenvalues and eigenvectors. For this, K minus lambda m mod is equal to 0. So this is simple. This is 4K, okay, K minus lambda m, okay. So K is here 4K, so we have taken 4K minus lambda m, okay. Here m1, m2, m3 is simply m0, 0, 0, m0, 0, 0, 0.5 m, okay, it's lambda m, okay. So that's why 4K minus lambda m minus 2K, here it is 0, okay. So minus 2K as it is, 0 as it is, minus 2K as it is, okay. 4K minus lambda m, so lambda into m, here minus 2K as it is because this term is 0, so lambda becomes 0, lambda m terms become 0. Next 0 as it is, minus 2K as it is. Now 2K minus 0.5 m, 2K minus lambda into m by 2, okay, no problem. Now we have to take the mod of this, okay. So we know that how to take the mod. So basically it is this value, that is 4K minus lambda m into the product of these two, okay, that is 4K minus lambda m into 2 minus lambda m by 2 plus minus minus plus into 2K into 2K, okay. Next minus 2K into, now this time this value multiply by this value, and then here it is 0, so no need for multiplication, and third one is this value is 0, so no need for multiplication. So if you solve this, you will get this value, 0.5 m cube lambda cube plus 6k m square lambda square minus 18 m k square lambda plus 8k cube is equal to 0. So this is the, after solving this, that is mod of k minus lambda m. Now how to solve this equation? So just a minute. Now this will take little mathematics. So this was our equation, minus 0.5 m cube lambda cube plus 6k m square lambda square minus 18 m k square lambda plus 8k cube. So what we will do, we will divide the entire equation by 0.5 m cube, okay. You just follow the process. If you divide this by m cube and taking k by m common and taking out, so you just follow this. What will happen here it will become lambda cube. Okay, 12 k by m lambda square plus we are multiplying by minus 0.5, that's why plus 36 k by m square lambda minus 16 k by m lambda cube is equal to 0. Okay, here we are putting lambda is equal to x into k by m. Okay, so if you substitute here, you will get this equation. So this is very simple way. Okay, or you can simply follow this, just replace here by x, even you can get the same. So our equation become x cube minus 12x square plus 36x minus 16 is equal to 0. Okay, instead of lambda just put x, you will get the answer. For cubic equation x cube ax square plus bx plus c is equal to 0, any integer root must be factor of the constant term. Okay, so we have to find first the factor which satisfy this equation. Okay, so you can do trial and error like 1, 2, 4, 8, 16. These are the factors. You can put these factors here. Okay, that is both plus and minus. So you have to put plus 1 instead of x, and you have to see that you are getting 0 or not. Okay, so this is a trial and error method. I will directly show you. If you take x is equal to 4, then 4 cube minus 12 into 4 square plus 36 into 4 minus 16 is equal to 0. So it becomes 0 if you put x is equal to 4. That means x minus 4 is a factor of the equation. First thing. Now write here 4. Okay, synthetic division method. Write here 4 and then write the coefficient here. X cube coefficient is 1, x square coefficient is minus 12, x coefficient is 36, and this minus 16. Okay, take this one as it is. 4 into 1 4, minus 12 plus 4 is minus 8, into 4 is minus 32, 36 minus 32 is 4, 4 into 4 16, minus 16 plus 16 is equal to 0. This 4 is due to we have determined this factor. Okay, so this equation will become x square minus 8x plus 4 is equal to 0. Now you can simply solve this equation, that is quadratic equation. A is equal to 1, the coefficient a is equal to 1, b is equal to minus 8, and c is equal to 4. We know that x is equal to minus b plus minus square root of b square minus 4ac upon 2a. Just put the values, and if you solve this, you will get the value of the roots. x1 is equal to 0.53589 and x3 is equal to 7.46410. Why I have written x3 here is, I will tell you. Okay, so here you can see, as we have determined these factors, zero point 53589, so our lambda will become 0.53589 into k by m. Lambda 2 will become, this is our factor 4k by m, and lambda 3 will become this factor 7.464 k by m. We have to arrange this in increasing order. Okay, that's why I have taken 0.53589 first, then 4, and then 7.464. Okay, because we need to arrange this in increasing order. So this becomes our fundamental frequency, natural frequency, the lowest one. Now it is very simple. whatever k value you have in your problem, whatever m value you have in your problem, just do the multiplication, you will get the lambda 1. Okay, and to get omega 1, that is natural frequency, fundamental natural frequency, omega 1, it will be equal to square root of lambda 1. Similarly, omega 2 is equal to under root lambda 2. Omega 3 is equal to under root lambda 3. So here we have just put the value of k as 12ei upon L cube. Okay, so this is how you will get the natural frequency, the first natural frequency, this is second and this is third. Okay, so we only put here, I will show you omega 1 is equal to 0.53589 into k is 12 ei upon L cube or h cube into m. Okay, and this is under root. So this multiplication under root we have taken out, that becomes 2.535 under root of ei upon m L cube. So here they have used h cube instead of L cube. Okay, now our next step is to determine the mode shapes. Okay, so first we will determine the mode shape for this value, that is for first frequency. So just a minute. Yes, so I will show you the calculation for the mode shape. You can do similarly for other shapes also. So mode shape, so we will start with lambda 1, which is 0.53589 k by m. So to get the values, we have to solve one equation, and that is k minus lambda m into phi is equal to 0, and this is the mode shape vector. Right, so here you know that this k minus lambda m, this matrix is with you. In this matrix you have to put the value of lambda, that is lambda 1, that is 0.53589, okay, into k by m. So m get cancelled and it will become k. So it is simple, wherever there is a lambda you have to put lambda 1 value. So this becomes 4k minus 0.53589k, m gets cancelled, minus 2k, 0, minus 2k, 4k minus 0.53589k, minus 2k, 0, minus 2k, 2k minus 2, 0.2679k, into, this is mode shape vector 511, 521, 531. That means 511 means this is mode shape 1, and this is floor 1, displacement of floor 1. Similarly 521 means mode shape 1, and 52 means second story displacement. 531, that means in mode shape 1 the displacement of the third story. Okay, so if you solve this, you will get 3.464 minus 2k, 0, minus 2k. Similarly if we solve this, 3.464k minus 2k, 0, minus 2k, and if we solve this, this becomes 1.732k into 511, 521, 531 is equal to 0. Now simply do the multiplication. So 3.464k into 511 minus 2k into 521 is equal to 0. We'll skip this because we want to reduce the calculation. So we'll take this. So 0 into 511 0 minus 2k into 521 and 1.732 into 531 is equal to 0. Now here generally we assume the top story displacement equal to 1, because in mode shape we are not finding exact values, we are finding the relative displacements. Okay, so we consider the top story displacement as a 1, so our 531 becomes 1. So if we solve this, minus 2 521 plus 1.732 into 1 is equal to 0. So if we take, so 521 will become minus 1.732 upon this 2 minus 2, then 521 becomes 0.866. Now simply put this 521 here, you will get 511. Okay, so 511 is 0.5, 521 is 0.866, 531 is equal to 1. Similarly, same way you have to repeat the process for lambda 2. And yes, this is the first mode. As I told you, the top story we consider displacement 1, second 0.866, third one is 0.5. So these are the relative displacement, and this is the first mode shape, right? If you solve the second, you check the values. Are you getting 512 minus 1, 522 0, 532 equal to 1? As I told you, here it is 512, 522, 532, means this is the second mode shape, and first floor, second floor, third floor. So here you can see 532 is 1, then 522 0, and 512 minus 1. So this is the mode shape second. Similarly, if you put lambda 3 equal to 7.464k by m, you can get 513, 523, 533, that is third mode shape, first floor, second floor, third floor. So here you can get such a mode shape for the third mode. So this is how you find the natural frequency and mode shape. Now the last problem was to check the orthogonality. So what is orthogonality property? For this you have to consider the mode shape. Any mode shape vector, you have to take the transpose, multiply it with mass matrix, multiply this with another mode shape, then it will becomes 0. We have to check this becomes 0 or not. Similarly, you can check, take the mode shape transpose into k vector into phi n, that is any another mode. So instead of going to a general form, I will show you one example. So here we will take the transpose of mode shape 1, multiply this with mass matrix into mode shape 2. That means these two mode shapes needs to be different, and you have to take the transpose of the first one. Okay, similarly you can check for phi 1 transpose em phi 3. Similarly, you can check for phi 2 transpose m phi 3. In all the case you will get the answer 0. Similarly, you can replicate for k also. Okay, so phi 1, that is mode shape 1 transpose, instead of vertical we will write horizontal because we have taken the transpose 0.5 0.866 into 1. This is our mass matrix, diagonal matrix 1 1 0.5. M is common into mode shape 2, that is minus 1 0 1. If you solve this, you will get the answer 0. And similarly, for all the case, you will get the value 0. This is how we prove the orthogonality property. So I hope this problem is clear to you. If you have any doubt, you can ask me in the comment box. I will surely reply. Thank you. Please like, share, subscribe the channel. Thank you. Thank you so much.